Hello everyone, welcome to this video. In this video, we'll be looking at the cyclic notation in permutation groups. So this notation was first introduced by French mathematician Cauchy in the year 1815. So this was a mathematician and the year was 1815, right? So using this notation, why do we use this notation? Because it makes to study the properties of permutation more easy for us, right? Lesser calculations are required in this case, right? So how do we write cyclic notations after having to know, after getting to know various advantages of this? Let's see why and how can we write the cyclic notations. For that, what we do, we consider a permutation. The set here is taken to be that which goes from 1 to 6, right? So all the elements are listed here and the corresponding permutations, they are listed here, right? So all these permutation, 1 is taking to 2 and 2 is going back to 1. So that means they are just the reverse of each other. So 1 is going to 2 and 2 is going to 1. So when you apply alpha onto 1, you are getting 2, and when you apply alpha onto 2, you are getting 1. So this completes one cycle, one complete cycle you can see here. Next, for the next element here, 3 is mapping to 4 and 4 is mapping to 6 and 6 is mapping to 3. So you see we reach again at 3. So this complete our cycle here. So we start with 3. It is when you apply alpha onto 3, you are getting 4. When you apply alpha onto 4, you are getting 6. And when you apply alpha onto 6, you are getting back again the number 3. So this completes one cycle. Next, you can see that for the element 5, that is the only element which is left, 5 is taking 5 to itself, right? So that means when you apply alpha onto the element 5, you are getting back 5. So this completes one cycle because it is moving on to itself, right? So here you see this form of cycle. So we have 3 cycles in this case, right? And 1 is taking to 2, 3 is going to 4 and 4 to 6 and 6 to 3 and 5 is going to itself, right? So drawing such diagrams repeatedly in some cases is cumbersome. So what do we do then? We actually leave out the arrows and write down the cycles in this form where we have 1 and 2 within one cycle. So we put them in one bracket with commas. In another bracket which represents a different cycle, we have the numbers 3, 4 and 6 with us. So we write it like this: 3, 4, 6. And for the last element 5, we have only one element, right? So this is the notation that we use. Let us take another example. Consider the permutation beta, where it is defined in array form like this. So here we have to list down the cycles. For that, we may start with 1. 1 is taking to 5, right? 1 is going to 5. 5 is going to 2. 5 is going to 2. And then 2 is going to 3. 2 is going to 3. And then 3 is going to 1. So 3 is again going to 1. So that means this complete one cycle. So you can remove the arrows and write down it in this form: 1, 5, 2, 3. Here the order does not matter. If you start from the number 2, you will be getting this thing: 2, 3, 1 and 5. 2, 3, 1 and 5, because we have a cycle over to this one, right? And for the next cycle, let's see what are the elements remaining. So we have 4 is going to 6 and 6 is going to 4. So 6 here going to 4 completes the cycle here, correct? So in this way we have 6 and 4 as the cycle. You can also write this cycle first and then this cycle, because they are independent of each other. They do not have to do anything, right? So we have these two cycles. So this is the notation. Next, let us see here, that is what I have written, the order of different cycles. It does not matter in this case. To simplify the notation further, what we can also do here is we can remove the commas as well, right? For example, the cycle 2, 3, 1, 5 could now be written as 2, 3, 1, 5, representing the same thing, and that the cycle which here is represented as 6, 4 could now be written as 6 and 4. So here commas also doesn't matter, and it's save us a lot of work when we have to do multiple calculations, right? So this is also one thing to note. Another thing is that if we have a cycle of this form, or after removing commas it is of this form, then we call it, because here we have how many elements with us? We have m elements with us, so therefore it is called a cycle having length m, or it is also called an m cycle. Moreover, a cycle which is having length 2, that is called a transposition. Correct? So I hope you understood this one. Well, that is it for this video. Thank you for watching.